Okay, so this is just our first video on surds, and I'm just going to introduce it by talking about squares and square roots. So let's have a look at perfect squares. What are our perfect squares? Well, 1 squared is 1 times 1, so that's what squared means. It means multiplied by itself, and 1 times 1 is 1. 2 squared is 2 times 2, and that's 4. 3 squared, 3 times 3 is 9. 4 squared is 16, and so forth. And so here's all our perfect square numbers in this column here. These are all our perfect square numbers. 6 squared, 36. 7 squared is 49. 8 squared, I'll just finish doing them. 64. 9 squared, 81. 10 squared, and I won't keep going. But then it's 121, 144, etc. So here is a special sort of, these are our perfect square numbers, and they are really important in surds, which I'll explain more in a second. Terrible drawing, isn't it? But that's okay. You don't care, do you? And so these are all our special numbers, our perfect square numbers. These are our perfect squares. They're all numbers that are multiplied by themselves. And so what this means is that the square root of 1 means what number do you multiply by itself to get 1 is 1. What's the square root of 4? Square root of 4, what number do you have to multiply by itself to get 4 is 2. So it's just the opposite of this process that we did, the square root. 9, what's the square root of 9? It's 3, because it's 3 times 3. What's the square root of 16? 4, etc, etc, etc. So that's what we're talking about. The square root down here, the square root of 121 is 11. It's the number, it's the opposite. Instead of going in that direction, we're now going in the opposite direction. Okay, and so that's what we're talking about with perfect squares and square roots. Hopefully you know that already, but that's just like an introduction to surds. So what are surds? Well, surds are just square roots of things, so I'll just say A, the square root of a number where A is not a perfect square. Oops, I always do that. Still getting used to this sort of thing. Yeah, sorry about that. I'll just scroll it down a bit. So we've got square root of A. So, because if you think about it, if you do the square root of 16, that's just equal to 4. That is not a surd. Because because 16 is a perfect square, it comes out nice. What is a surd is like, say, the square root of 17. 17 is not a perfect square, and so that comes out as something nasty, and if you do that, you get 4.1285, and it'll just go on forever and ever and ever. Okay, to get this horrible decimal. That is a surd, and we call it a surd because 17, the number under the square root sign, is not a perfect square. So that's basically what a surd is, and I'm going to show you how to add surds, multiply surds, subtract surds, divide surds, and that sort of thing, and let's do that now. So firstly, let's do multiplying surds first. Okay, so basically if you have some surd square root of A and you multiply it by square root of B, nice and simple, what it turns out to be is A times B under the same square root sign. So this is really simple. In other words, root 3 times root 7 is just equal to the square root of 21. And it's that simple, nice and easy. You just multiply the two numbers together and they end up under the square root sign. Okay, another example, let's just do one more. Root 5 times root, what's a good number? 8, something like that. If I multiply that together, you guessed it, it's root 40. So multiplying is really, really simple. And you can go both ways, obviously. If you've got root 40 like this, you can write that as root 8 times 5. I could write that as root 4 times 10. What's another one? 2 times 20, anything like that. You can write these as, expand them out. There's no reason you can't do this. Root 4 times root 10. There's root 2 times root 20. So these are all equivalent. We're allowed to do this, all these things. I'll underline all of these things. So that is equal to that, is equal to that, is equal to that. They're all the same thing, they're all equivalent here. And this is a really important thing in Surds to understand, that these are all equal to the same thing, because we can just do this multiplication that we can either put it all under the same square root sign or we can take it all out. We can go either way here. And this is very important. And so now let me go on to simplifying Surds. So just start a new page and show you how to simplify Surds. Simplifying, okay. Let's start with root 8. Now, what we're looking to do is we look at the number 8 here, and what we're trying to do is simplify it so that it's in its simplest Surd form, and I'll show you what I mean by that. Before I start, over here I'm just going to write down all the perfect squares. What are they? 1, 4, 9, 16, 25, 36. These are all the numbers that something times itself. 64, that's 8 times 8, 9 times 9, 10 times 10, 11 times 11, I'll just go up to 12, there we go. These are our perfect, or I'll call them magic numbers, that's the numbers that we're looking for. When we're trying to simplify Surds, we're looking for factors of 8 that are in this list. Okay, what are the numbers in this list that go into 8? So think about the factors of 8, the numbers that multiply together to make 8. Can you find something in this list? Now 1 is a bit naff, we don't care about 1, it doesn't really help us, so let's think about it. Does 4 go into 8? Well, yes it does. And so what we do is we write this as, we said before that we can change this, so instead of writing 8, I'm going to write it as our magic number first, 4 times 2. So there we go, I haven't done anything, I've just changed, instead of writing 8 I've written 4 times 2, where that 4 is our magic number that comes from this list over here. Very important. Okay, and our multiply rule said that we can write this as a separate square root sign. So we can write that as root 4 times by root 2. We can take that apart like that. And the reason we've done all this, and you'll see this, what is root 4 equal to? Well, we know that the square root of 4 is equal to 2. So let's write that. Instead of writing square root of 4, let's write 2. So that's 2 times root 2. And in Surd notation, we don't bother writing the times. You know, in algebra, we don't bother writing the times. So this just is equal to 2 root 2. And that's our answer there. That's what we've done, is simplified this square root of 8 into this. And you'll see a bit later, I'll show this in class why this is important. Let's have a look at another example. How about square root of 50? Square root of 50. Okay, now let's have a look through this list. Does 4 go into 50? Well, no it doesn't. Does 9 go into 50? No it doesn't. 16? No. 25? Well, yes it does. 25 goes into 50. And so what we do is we write it as such. Let's write down our perfect square first, 25, and that's 25 times 2, again like that. Break the square root sign up into two pieces, the square root of 25 times the square root of 2. What is the square root of 25? The square root of 25 is 5. So it's 5 times root 2, and in maths we don't bother writing the times. 5 root 2. And so that's how we're doing simplification. I'll do two more. I'll do two more. So next one I'll do is, let's try, how about, let's do root 54. How about that one? That's a good example. Root 54, let's have a look. Does 4 go into 54? No it doesn't. 9? Yes it does. 9 goes into 54. And so this is a good little go here. Let's put 9 into that. So, how do we rewrite it? Write your magic number first, 9. 9 times what? 9 times 6. Great. Once we've done that, break it up into two pieces. Root 9 times root 6. Perfect. And then what is root 9 equal to? Well, root 9 is 3. So that'll be 3 root 6. And there we go. Nice and easy. Now, just one last thing before I'll just do one more example. Let's just do 2 root, let's do 2 root 32. Something like that. Okay. Now, what does this mean? Remember when we've got 2 root 32 like this, there's a little hidden multiply sign in there that we're not thinking about. So let's just keep that multiply by 2 out the front. What is a factor of 32 that's in our magic list here? 4? Yeah, 4 goes in. But just a little trick, we're always looking for the largest number from this list that goes into 32. You'll still get the right answer if you choose 4, but you'll have to do it again, like it will take more work. So let's just go through the list. 9, no, 9 doesn't. 16 does go into it. So 16 in this case is the number that we're after. Let's have a look at 16. So 16, so it'll be 2 times, and inside the square root sign, let's write our magic number first. 16 times 2. Perfect, okay. Let's break it up, still with that 2 times sitting out the front. I'm not going to change that. Square root of 16 times the square root of 2. Okay, so I've broken that square root sign into 2 pieces. So then it'll be 2 times, what's the square root of 16 equal to? That's 4 times root 2. And so that's what we end up with. Now we can just simplify what's come out the front. What's out the front? 2 times 4, that's just 8 root 2. And that's your answer there. So that's a bit about simplifying surds. Hope you understood it. We'll do some